Okay, hi guys. So in this lecture, we'll be starting off on seeing enthalpy. So let's get started. So it is represented with h. So h is a state function which is path independent, and it is an extensive property which is dependent on the amount of substance. H is a state function which means it is path independent and an extensive property. Okay, which means it is dependent on amount of substance. Okay, so the fundamental definition or fundamental equation of H is U plus PV, and similarly we can write in differential form that dH would be equals to du plus dPV. Okay, and we can also write that delta H is equals to QP, or rather this is simply called enthalpy, which is nothing but rather change in enthalpy is equals to heat given at constant, or rather heat exchange at constant pressure. Okay, next let us say, or rather have a case in which pressure and volume both changed in the process. So if pressure and volume both changes in a process, then we can write that we know that dH is equals to du plus dPV. Now when we integrate it, we can write it as follows: delta H would be equals to delta U plus delta PV. Again we can expand delta PV as and when required. Okay, or we can write that delta H would be equals to delta U plus P2 V2 minus P1 V1. Okay, let's say this is equation 1. Now let's have another case in which if volume is constant, then we can write we can write that dH would be equals to again du plus V dP. Okay, and on integrating it we can write that dH would be equals to du plus V delta P. Let's say this is equation number 2. Okay, now let's have case 3 in which pressure is constant, then we can write that dH is equals to du plus PdV, and on integrating it we can say that delta H is equals to delta U plus P delta V, which is equation number 3. Okay, so all the above relations are valid for any solid, liquid or gas. All above relations are valid for solid, liquid and gas. Okay, so now according to the first law of thermodynamics, we can write that du is equals to dq plus dw. Okay, and we know that dw would be equals to minus pdv. So just substituting the value, so we can write that du would be equals to dq minus pdv, or we can write that du plus pdv would be equals to dq. Now suppose we are having this at constant constant pressure, then we can write that dq at constant pressure would be dqp, and we already know that dh is equals to dqp, or enthalpy is nothing but heat exchange at constant pressure. So we can write the same. So this form we already know that this form is nothing but delta h or dh. So we can write dh would be equals to dqp, as we know that if pressure is constant, we can write delta h equals to delta u plus p delta v. So we can write that as this is enthalpy at constant pressure, so dh would be equals to dqp, or when we integrate it, we can write that enthalpy is nothing but heat exchange at constant, or rather change in enthalpy is heat exchange at constant pressure. Okay, so for example, if we have something like this, that heat released by the system at constant pressure is 50 degree joule, not degree, 50 joule, beg your pardon. So heat released by the system at constant pressure is, let's say, 50 joule, then delta h would be equal to minus 50 joule. Okay, and similarly, if we say that heat absorbed by the system at constant pressure is, let's say, 40 joule, then delta h in this case would be plus 40 joule. Okay, so with this we come to the end of this lecture. In the next lecture we'll be continuing on seeing more on enthalpy. So till then, good luck and goodbye.